I'm here with John Carpenter, who is the ALMA observatory scientist at the ALMA observatory headquarters in Santiago, and we've been discussing the science results of the last decade, with more to come from the 66 element observatory, which is now situated high up in the Atacama Desert, which is about, what, John, a 2.5 hour flight from here, isn't it?
It's about a 2-hour flight. Yeah.
And so you've been here for 4 years, originally from Wisconsin.
Yep.
And what's the most, you do a lot of research into molecular clouds and planet formation and circumstellar disks. How has ALMA, and it's the Atacama Large Millimeter and Submillimeter Array, it's a joint international partnership, cost of about $1 billion. Is that correct?
Yeah.
So what's been, from your own mind, the most exciting scientific results from this?
Well, I think one of the goals of ALMA when it was built was to look at how planets form. And so when stars are very young, they're surrounded by a disk of rotating gas and dust. And what ALMA is able to do is to obtain very exquisite images of those disks. And while we can't see the planets themselves, we can see potential impacts of those planets just through the force of gravity of basically structures they can form within the disk. They form gaps and they form rings. And ALMA, really for the first time, we can map those structures out with ALMA. And so, in refining that, just all of these disks are containing these structures, and it's giving us evidence that planets are forming very young, at a very young age around a star, which is very surprising. And so I think that's been one of the. It's really been close to people always overuse the word transformational, but it's really changed our picture of how often and how fast planets could be potentially be forming around these stars.
And what, for the lay person, for the average person, how would you describe a millimeter and submillimeter telescope?
Well, it's basically different telescopes look at different wavelength, what we call wavelength of radiation. And so our eye can detect what we call optical wavelengths. And so submillimeter and millimeter telescopes, they detect what we call wavelengths roughly around the order of a millimeter. So our eyes cannot see it directly. So it's intermediate between what our eyes can see, what optical, versus radio, which is, when you listen to the car radio, right? It's intermediate in between those type of frequencies or wavelengths.
But you are able to create images from your observations.
Yes, so we can create images, and so basically we detect images are basically the variation in intensity of radiation at millimeter wavelengths across the sky. So just like when you make an optical image, right, you're seeing variation in intensity. Just very similar to what at millimeter wavelengths as well.
And you also are doing observation of sunspots on the sun. Is that correct?
Yeah. So we observe a whole range of objects. So we're detecting. We can look at the sun. We can look at planets. We can look at moons within our solar system. We can look at Kuiper belt objects. But we are also detecting young stars in their formation, and we're also detecting galaxies that are forming very soon after the Big Bang. So ALMA is a very versatile instrument.
As far back as 500 million years after the Big Bang, you detected galaxy formation, and also the detection of oxygen back then. I mean, it's pretty incredible.
So we detected oxygen in a galaxy at a redshift of 9.1, and so roughly corresponding to just 500 million years roughly after the Big Bang. We're detecting the heavy elements or oxygen at such a young age. And
you expect the 25, maybe 30 more years out of this observatory, and you're hoping to do an electronics upgrade to expand your wavelength observations.
Yeah, so we can always make ALMA more powerful, and so over the next decade we're going to be upgrading our electronics so we can process more wavelength coverage all at the same time. And that's over the next decade. One could easily imagine, even further upgrades, in the following decade as well. But for the first, we're going to just focusing on upgrading the electronics.
Well, more power to you and your colleagues, and thank you so much for showing me around, taking a bit of your afternoon today. Thank you so much for having me here.
It's my pleasure.